In this video, we're going to look at composition of functions, or you can also call composite functions. So when we talk about composition of functions, we will have at least two functions, and we put them together and we make a new function. So that's called composition of functions. So for example, we have two functions. F of x is let's say 2x, and g of x is x minus 1. So we can put these two functions together. There are two possible ways to put them together. So let me draw the vending machine to represent these two functions. So maybe the first, when we put them together, there is an order, and the order does matter here. So maybe we can start with f function, and so when we put a number in here, say let's put x in there. So when the input is represented by x and output is represented by 2x. When we put an x in there, and we're going to see this function called f is going to change x to 2x. So we're going to get an output. So so this is called input, and we're going to get an output 2x. And then we're going to take this output 2x and put into the second function, g of x, and see what we're going to get. When we put it in there, what's going to come out? So this is the question. There is a different way. We can put g of x first and then do f of x. But let's go back to this example. Suppose I'm going to put a 1 in there. And as you can see, f of function doubles x, doubles the input x. So whatever you put in there, it's going to get doubled. And so in this case, x equals 1, we're going to get 2 out of f of x. And then we're going to take 2. We're not going to use 1 anymore, so we're going to use 2 that comes out for machine f of x, or the function, and we put 2 into the second function. So when we plug in here, the variable is going to become the input is going to be, input of the second function is going to be x equal to 2. So notice this x and that x, they're different. And maybe not to confuse you, you can just look at, so when we put a number in there, and when this 1 will replace x, and we get a 2. 2 times 1 is 2. And then we're going to put 2 in here, and this number 2 is going to replace the x in the g function. So we're going to get 2 minus 1, which gives us 1 as output. Well, in this case, it's just a coincidence that we get the same number as we start with, but normally it's not going to be the same. So let's try to put a 3 here. If we put 3 in here, this 3 replace x, we're going to get 6, because 2 times 3 is 6. And then we're going to put this number 6 into the second function. And the 6 will replace x in the function. So we do 6 minus 1. That gives us a 5. So every number we put in here, instead of going through one machine, it goes through 2 machines. We put it in there, we get a new number, and we put it in the second function, we get a different number, another number. And so together, that's called composition. And so in general, we want to, so how to summarize the steps here, how do we do this kind of question? So of course, we're not going to, when we do the problem, or when we create a symbol, we want to make it easy. We don't want to draw vending machines every time. So these two functions join together. We use a symbol to describe it from right to the left. I'm going to explain why we do the right to the left in a second. So we put a f first, following the order. The first function we did is f of x, and then the second function we did is g of x. So we're going to start with f and then go to the left. So this is a little different from the normal order. When we read or write, we go from the left to right, but here we go from the right to the left, and there's a reason for that. So in this case, what we just did, for example, if the input is 3, that means this x is 3. So the function we got is called the composition of G and F. And if this X takes 3, what are we going to get? And you can see why we put F first, because F as 3 as an input of F, because 3 goes into F, and you're going to let me use the vending machine to help us to understand this for a second. So when we put 3 into the function F, it's like replacing this X with a 3. So we got an answer which is 6. And then we're going to take the 6 and put it into the second function, which is like this. We do the next one because this 3 has to go with the F together. So where are we going to put a G? And if we put it, say right here, and this is, we get a 6, and the 6 sort of like in front of the function G, but usually we like to put the input at the end of after G. So that's why we move the G in front of F. And when we get an answer from F of 3, let's see here, when we get an answer, this F of 3 is going to be 6, and the 6 will go through the second function G. So that's why we put a G first. But there is another way to write the function. If you don't use this open circle, you could use 2 parentheses. So first you do F of 3. When you get an answer, you're going to put it as an input of G. So that's another way to write it, to use another pair of parentheses to include F. And this whole thing will become the variable of the input of G. So there are 2 ways to write it. So similarly, if we change the order, you could put G of X first. And that will give us G of X first, goes through the G function. And then when you get an answer, and it goes through the F function. So it's G and F are switched, and the answers will be different. So we can see what if we switch them. Let's say G of X first, that's X minus 1, and then goes through F of X to X. And now we put a number in here. Let's say we can still put 3 in here. 3 replacing, when 3 goes through G function, replacing X with 3, we get 3 minus 1, which gives us 2. And then we're going to put 2 into the F function, replacing this X with the 2. That gives us a 4, and which is different from what we got previously. 3 goes through the first F, we got 6. 6 goes through G, we got 5. But when the order is switched, as you can see, we get different answers. So we have to make sure we know which one goes first. And so when we talk about composition of functions, you may have 2 different orders. So now let's look at the steps to do the question. You can one way you can do is sort of like following this graph here. First step, you're gonna find out if they ask you to find what G, the composition of G and F is with the variable 3. We can first do F of 3. So that would be our step 1. So let me write down the steps here. Step 1. Okay, and also I'm going to write down the questions clearly. So we are given these 2 functions, F of X and G of X. We want you to find F and G at 3. And we also want you to do another question, but we can with the order switch, but we're going to do that next. Okay, so sorry, I should have then switched G and F, because I have, in this graph, I have F first. So step 1, following the graph, we're going to do this. That's our step 1, F of 3. F of 3, which means we replace the X in the F function with 3. So we're going to get 2 times 3, that's equal to 6. And when you get answers, this box will become the number 6. It's going to be the result of this box will be 6. So we're going to do step 2. As shown in the graph, we take this number 6 and we plug into the G function. So geometrically, this is what we do. So we have a G now, but this is gone. This is worked out as 6. So we're going to put 6 into the G function. So when you do that, which you're going to replace x with the number 6. Replace x with 6, so we get answer 5. So you can do 2 steps when you do this question. So that's solution 1. If you don't want to do 2 steps, you can write them the way we looked before. So you can, so how do we do G and F of 3? You can copy the letter G here and work this out first. When you work that out, you plug a 3 into the F function. So you got a 2 times 3, which is G of 6. So you just keep copying that letter G and G. And when you get an answer, and then you plug G6 into the G function, G minus, you still have to do steps, but you just didn't separate them, you put them together. So this is still would be your step 1. When you get an answer from step 1, this is the answer from the step 1. And then you do step 2. This is our step 2. And plug a 6 into the G function, second function. So similarly, if you want to switch them, and you're going to do the same way. But I want to do a different example. So we want to give you